Hello friends, welcome to our channel. In this lecture, I would like to explain another important example based on the topic slope deflection method. Already in the last lecture, that is in example 4, I solved the problem based on the fixed end conditions. But here you see this problem which is the simply supported end conditions at A and D. So before going to problem, check whether the conditions satisfy for the sway analysis or non-sway analysis. So for sway and non-sway, what are the differences here? So same end conditions, same end conditions. Here different end conditions. Okay, and see here symmetrical loading, symmetrical loading. Here unsymmetrical loading and equal heights of the column, equal heights of column. Similarly here unequal heights of column. Here equal moment of inertia means constant. Here unequal moment of inertia. So these are the conditions happen for sway analysis and these are the conditions happen for non-sway analysis. So if you observe here same end conditions, equal heights of the columns, equal moment of inertia means I. So if not mention any value for I means property means that one will be equal to 1 and that is I. And here equal distributed, not eccentric point load, only point load acting exactly at the center means here symmetrical loading will be happens. So based on these conditions the frame will comes under the non-sway analysis. Okay, then our first step is used to solve the fixed end moments. So each and every time repeatedly I am explaining the conditions for the sway and non-sway analysis. Why? Because it is very important to know whether it will comes under sway or non-sway analysis. For example, if the problem comes under the sway analysis, you can solve a non-sway analysis means the basic concepts itself wrong. That is the reason I am explaining each and every time the conditions of the frame. So our first step is to solve the fixed end moments. Fixed end moments. See here, what about the fixed moments? For column AB means M bar AB, M bar BA equal to 0 because there is no loading condition is given. There is not no horizontal force acting on the column. So if there will be no force acting on a column means definitely the final fixed moments will becomes 0. Similarly for column CD and DC also. Same like as example for columns AB and BA, CB and CD final moments are fixed moments are 0. And what about fixed moments of BC? So which is denoted with M bar BC and a point load is acting center means the formula will becomes minus WL by 8. If you substitute the values means minus W equal to 12 into length of the beam will be equal to total 2 plus 2 4 meters divided by 8. Cancel the possible terms, 4 1 times 2 times, it will cancels again 6 times, 6 kilonewton meter. And again next one M bar CB will be equal to just change the value plus WL by 8, that one will becomes plus 6 kilonewton meter. So this is the procedure for finding the fixed moments. After finding the fixed moments, immediately calculate the slope deflection final moment based on the slope deflection equation. So for span AB, we are talking about the starting again span AB. So I already told you, I will show you both the difference of the formulas for the fixed end conditions and the simply supported end conditions. So what is the general slope deflection equation? So that one will be equal to MAB will be equal to M bar AB plus 2EI by L into 2 theta A plus theta B minus 3 delta by L. If sinking of the supports is given, then only this delta will be considered. Otherwise, it will be 0. So, this is the standard slope deflection equation. So, when this equation will be obtained? This equation will be obtained when far end conditions are fixed. Okay. But whenever far end will be simply supported, at that time the formula will be changes to m bar AB minus m bar BA by 2 plus 3EI by L into theta B minus delta by L. Again here this delta also for the sinking of the supports. Means you always see here far end is simply supported condition. Simply support condition. So while explaining the continuous beams, each and every time I used to talk about the what is the fixed far end, what is the near end. So see here in this frame at end A it is simply supported, at end B is the intermediate support. Intermediate support always considered as the fixed support. Okay, here also intermediate support which is considered as fixed, and here also end which is considered as simply supported. Then again you please remember one more thing, while calculating the span MAB, you directly take down moment for MAB will be equal to 0. So always at the simply supported end the final moment will becomes 0. No need to calculate here. At the same time observe here MDC also. MDC also directly take down 0. Even though if you want to simplify means A is the near end, B is the far end. Far end fixed condition means you will get this first formula. So what I am telling, if you want to simplify this MAB, then also you will get 0 only. But what is the condition we are taking? Far end fixed condition. So A is the near end, B is the far end. So B is the far end means intermediate fixed support condition will be there. Then you can take down directly this formula. Substitute m bar AB will be equal to 0 plus 2 EI by L. Here theta A and theta B are the slopes you will get, and sinking of the support will be 0. But we are using modified formula for the simply supported problems. Why? Because if you take down this formula means then you will get slopes at A and B, C and D. There will be 4 unknowns. Again you can take down simplifications in better way means you can calculate 1 into equations like that. Therefore, if you use this modified formula for the simply supported end conditions, then at that time this formula becomes the problem solving of the problem becomes very easy. So I will show you here. So MAB and MDC will be equal to 0 because of the simply supported end condition. Whenever hinge support is given, whenever simply supported condition will be given, support will be given, you please take down that end will be 0. So that final moment will becomes 0 directly without any calculation. Then take down MBA. See here MBA. So equation MBA means, so see here we are at B A column. So moment for BA means A is the far end here. So for it will be near end and this one will be far end. So support B is near end, A will be the far end. So see here whenever far end is simply supported, what I told you means directly use this formula. So that one will be MBA will be equal to M bar AB minus M bar BA by 2 plus 3EI by L BA into theta B. So this is the formula. You just use this formula and substitute the value directly. So M bar AB will be equal to 0 minus M bar BA also 0 because of the fixed moments are 0 plus 3EI I value will be I only because of the constant, and L is the 4 meters here, theta b. So after simplifying, you will get MBA value directly will be equal to 3 EI theta b by 4. Then go for the next step, which is MBC. MBC, which is span BC. Okay, so we are at B and looking C. C is the far end intermediate support, which is considered as the fixed one. Okay, which is considered as the fixed one. So that one will be equal to M bar BC minus M bar CB by 2. Sorry, you can use directly far end fixed support formula, M bar BC plus 2 EI by LBC into 2 theta B plus theta C. Okay, then substitute the values in the formula, and again here also the frame will comes under the symmetric condition. Therefore, consider theta C will be equal to theta B. In the previous problem, we have two important note conditions. Due to the fixed end, theta A and theta D will be equal to 0, and again theta B will be equal to theta C will be equal to minus theta B. So here directly take down only this condition. Because of the simply support end conditions, we are not taking that one because you will get some slope here, but the final moment itself 0 here. So M bar BC will be equal to, what is the value? After simplifying, you will get minus 6 kilonewton meter. Minus 6 kilonewton meter. Then plus 2 E I will becomes I only. Length of the span will be 4 meters into 2 theta B, and wherever theta C, substitute minus theta B. So 2 theta B minus theta B becomes theta B, and again simplify, minus 6 plus 1 by 2 times 1 by 2 EI theta B. So after simplifying, you will get this equation like this. So if symmetric conditions happens, then take down up to that condition and simplify remaining values also. So what is the procedure? Already I explained. Means sigma MB will be equal to 0, means sum of the moments at that particular joint B will be equal to 0. Take down MBA plus MBC will becomes 0. Okay, so what is MBA here? So I am talking about this joint. Sum of the moments at this particular joints will becomes 0. MBA plus MBC. Take down that equilibrium condition. So MBA will be equal to 3 EI theta by B by 4. That is 3 EI theta B by 4. And this BC will be equal to minus 6 plus EI theta B by 2 equal to 0. If you simplify this one, you will get take down LCM here, 4 2 common as 2. So which is 4 3 times of EI theta B, and again 2 times 2 EI theta B equal to 6. So like that, again send this one this side, 24 divided by 5. So finally if you simplify, you will get EI theta B value. That value will becomes, so after simplifying you will get EI theta B value will be equal to 4.8. So you will get EI theta B value is 4.8. So after obtaining this value, what you have to do means you substitute EI theta B in the above equation here, 3 by 4 into 4.8. It will goes around 1.2 times. So how much you will get here? 3.6 I think. Okay, this one will be 3.6, which is in positive terms. And again simplify here, minus 6 plus 4.8 by 2. So it will goes around 2.4 times, minus 6 plus 2.4. How much? Again here it will be minus 3.60. And another moment AB will becomes 0 here because of the simply supported end. So based on this, so you will get the moments of MAB equal to 0, MBA will be equal to 3.6 kilonewton meter and MBC will be equal to minus 3.6 kilonewton meter. Similarly, based on this sense, you can write down MCB value. So this one will be 3.6 kilonewton. MCD value and MDC value. So almost MAB will be equal to 0 means final moment MDC will be equal to 0. And this one will be minus 3.6 means this one will be plus 3.6 kilonewton meter. And again reverse to that one minus 3.6 kilonewton meter. Okay. So sum of the moments at this particular joints will become 0. Sigma MB will be equal to MBA plus MBC. Similarly, sigma MC will be equal to 0. Sigma means MCB plus MCD will become 0. So this is the way to find out the final moments for this type of symmetric condition problems. But you can do this problem manually. See here, what I am telling means, after obtaining these three equations, after MBC, what we have to do means, again you can calculate MCB manually. MCB. Again you can calculate MCB means, what you have to do means, see here, for calculating MCB, what we have to do means, same for and fixed support condition, take down the formula M bar CB plus 2EI by LCB into 2 theta C plus theta B. Again M bar CB will be equal to plus 6, 2 by 4 EI, 2 theta C will be equal to minus theta B. Why? Because already we take down that condition. Due to symmetry, it will becomes theta C will be equal to minus theta B plus theta B. Here plus 6 and entire value becomes minus theta B and it will cancel 1 by 2 times, plus 6 minus EI theta B by 2. So this is the equation after simplifying, and again go for MCD. So MCD means for and simply supported condition. Again use the formula M bar CD minus M bar DC by 2 plus 3EI by length of CD into theta B, theta C. Okay, and again substitute all the values, 0 minus 0 plus 3EI theta C means take down minus theta B by its length like 4. And again MDC will becomes 0. After obtaining all this equation, take down each and every equation. This one will be 4, this one will be 5, and again first two equations will be, so there will be only, see the equations from starting. How many equations obtained here? So in the span MBA, this is the first equation and this is the second equation, and MBA BC, and for MCB this one will be the third equation and this one will be the fourth equation. After obtaining this one, again find out the equilibrium condition at B. For that one, sigma MB will be equal to 0, that one will be MBA plus MBC equal to 0, and again equilibrium condition at C. For that one, what we have to do, sigma MC will becomes 0, that one will be equal to MCB plus MCD equal to 0. So after simplifying, again there will be two unknowns in the form of theta B and theta C. So simplify those two equations, again substitute those two values in the entire equations, two slope values in the entire four equations. You will get each and every value individually, every final moments individually. But whenever symmetric conditions happens, no need to solve entire equations, just to solve one equilibrium condition, then write down the remaining values. on the logical way. Okay, so in what way I have to calculate, I will given the procedure also in the previous problems. For example, if you observe the continuous beams, there I explained each and every problem very clearly. In the next problem, while solving the frames itself, there will be no symmetric conditions happen. I will take such type of example, and I will solve each and every span, and I will simplify up to entire equations also. Okay, but for the symmetrical frames, you no need to calculate each and every equation. Just calculate MAB, BA and BC. So based on the equilibrium condition, whatever the slope you will get, substitute in the obtained equations. Then whatever the final moments obtained for these three conditions, you can write down the remaining three conditions with their opposite signs. Friends, this is the way for finding the fixed and final moments for this type of problems. After obtaining the final moments, just draw the bending moment diagram and calculate the horizontal and vertical reactions directly. So please draw the bending moment diagram. See here, MAB will be equal to 0. MAB will be equal to 0. Therefore, at A, this B, this one will be C, and this one will be D. MAB will be equal to 0. This one will be at this position only 0. And MBA will be clockwise 3.6 kilonewton meters. Means a movement will be acting like this. So according to our condition, whenever a force will be acting like this, like this. So what happens? It will move like this. So this B will be comes up to here. So that unit value will be around 3.6. So after that we can add these two like this. In the same way, another movement like for BC there will be an anti-clockwise movement acting here. So whenever a force comes and act like this B will be moves up to here, that is 3.6 kilonewton meter. In the same way, another movement CD. So clockwise movement is acting at CB, and again whenever a force comes and act like this, it will move up to here. So that one will be 3.6 kilonewton meter. So you can draw those two lines and draw like this. Okay. Same way, just you can draw for the symmetric condition, whatever the diagram you will get here, in the same way you will get just opposite to here. Or else you can see here MCD, anti-clockwise movement is acting here. So based on this force application, the beam column will tends to move up to here like this, and again D will become 0. So this is the model for drawing the bending moment diagram. So I will draw here. So this is the bending moment diagram. You can draw this one based on the hogging and sagging also. Okay, so this is the bending moment diagram, which is the fixed bending moment diagram. So you can draw the free bending moment diagram based on the given loading condition. So here point load is given. See here point load is given. Whenever point load is given, you will get free bending moment diagram is in the form of the triangular load. So exactly at the center point, ordinate point. So this value will be, so see here this one will be 0 and this one will be 3.6 and this one also 3.6 and this one will be 3.6, this one will be 3.6 and this one will be 0 again here. So what is the overall ordinate value here? The overall ordinate value will be equal to WL by 4. Whenever a point load is acting exactly at the center, the area of the bending moment diagram will be calculated in the form. So that is the maximum bending moment will be calculated by using this formula, which is WL by 4. The given value will be 12, length will be 4 and over by 4, which is 12. So taken from here to here, it will be 12 kilonewton meter. And if you want net moment, so what we have to do? 12 minus this entire this ordinate triangular load minus this rectangular load minus 3.6. You will get 8.4 around. So that is the net bending moment value. Friends, this is the way to draw the bending moment diagram and to find the net bending moment value. After finding this one, you just calculate the horizontal and vertical reactions directly. So whenever a symmetrical loading conditions is given, so you just assume the directions of the horizontal reaction. I am myself assuming the direction towards right and I am indicating HA. So what I told you for calculating horizontal reaction, so the formula will be sum of the moments, means sum of the column moments or moments on the columns divided by its length of the column, divided by its length of the column. So what are the sum of the column moments? So on a AB column, AB is one moment, BA is another moment, that is 0 plus 3.6 divided by 4. How much you will get? How many times it will go? So around 4 9 36, that is 0.9 kilonewton. So like that you will get the value directly if you calculate by using the formula. So I already shown you manually by procedure. Take down sigma MB equal to 0 and resolve the forces up to the B. Like that also I shown you in the last problem very clearly. But no need to calculate all these things. Directly you can take down in the formula whenever no horizontal forces is given on the column. Then HB will be same due to the symmetrical condition. You will get minus 0.9 kilonewton. So if you can assume the direction towards right, you will get minus 0.9 kilonewton because there will be one minus 3.6 plus 0 by 4. Then you can change the direction like this and change the sign also. Okay, so that is the way for finding the horizontal reactions. And again, so find out the vertical reactions. So vertical reactions is also very easy. I told you in the last problem also. No need to do any type of calculations. Just you people know that whenever a point load is acting exactly at the center on a simply supported beam, the load will be distributed equally. Like this 12 will be distributed here 12 by 2, that is 6 kilonewton. Here also 12 by 2 6 kilonewton. Means you can analyze the problem like that and directly do the calculations. You can do manually also, like sigma MD will be equal to 0. Then what happens? VA into 4, which is acting clockwise, therefore I am taking clockwise moments one side, anti-clockwise moments another side. So VA into 4, VA into 4 acting clockwise. And again, is there any clockwise moment acting here? So I think there will be clockwise positive moment is acting plus 3.6 and minus 3.6, MCB will be plus 3.6. Due to symmetrical moments, entire moments will cancel. So no need to take any moments here. If there will be any difference in the moments, then only the moments will be obtained here. Then anti-clockwise movement is this force, downward force will be acting, that is 12 into 2, which is acting like this. VA into 4 will be acting like this. So one will be clockwise, another will be anti-clockwise. 12 into 2, so 2 times 2 1 times and 2 1 times 6 times. So VA will equal to 6. So sigma V will be equal to 0. VA plus VD, VA plus VD will be equal to 12 kilonewtons. Both upward forces equal to downward force, sum of the vertical forces will be equal to 0, means Va plus Vd will be equal to 12, Vd equal to 12 minus Va, that one will be equal to 12 minus 6, which is 6. Like that you can simplify manually, or else you can take down like this directly. So this is the way for finding the horizontal and vertical reactions. I hope you understand this lecture. In the next lecture, so up to here I solved both end conditions fixed and both end conditions simply supported in the even in the frames also. In the next problem I will take such type of problem like this. So another beam will be connected, so sum of the moments at a particular joint will becomes 0, means there will be three connecting members here E. So at this particular joints you observe, means there will be three connecting members like MCD, MCB and MCE. We have to sum these three final moments, then only you will get 0. So in what way you have to calculate that type of conditions? If there will be any horizontal forces, in what way you can calculate horizontal reactions? I will explain in the first lecture itself, that is in the example 4 itself in the frames. But we will solve one problem, another beam will be connected to the joint C or joint B. So then we will cover maximum problems in the slope deflection equation. After that again we will discuss about the sway analysis problem. So whatever the different end conditions or different column heights, we will take down such type of problem, and I will show you in what way we can solve the sway analysis based on the slope deflection method also. I hope you understand this lecture. Thank you so much for watching this video. If you really like this video, please like this video, share it to your friends and subscribe our channel. Thank you so much.